In this video, we're going to look at taking the limit as x approaches infinity. So our first example, we have the limit as x approaches infinity of 3x squared minus 1 all over 7x squared plus 4x minus 5. Alright, so there are some shortcuts to this. In algebra, I teach Bobo-Botten, bigger on bottom, bigger on top. And that gives you some information as far as a horizontal asymptote, which is effectively the same approach. But in this video, I am going to focus on the analytic approach to this. So anytime you have the limit as x approaches infinity, again, the first thing you want to do is what's happening as our function is going to infinity. So as x gets bigger and bigger and bigger, we're going to have x squared, which is going to make it even bigger, times 3, which is going to make it even bigger, and that negative 1 isn't going to really do a whole lot. In the bottom, so our top is going to approach a positive infinity. On the bottom, again, we have the same thing. X squared is going to get bigger, multiply it by 7, and it's going to be even bigger. And the bigger x gets, the more and more 4x minus 5 is not going to make a difference. So this one's also going to infinity over infinity. If you take higher level calculus, you may look at some other ways that you can find this limit, but the approach that we're going to use only requires an algebraic background. So we get infinity over infinity. That's what we call an indeterminate form. That means there's something we can do. In this case, what we want to do is identify the largest power of x on the bottom. In this case, our biggest power of x that we have on the bottom is an x squared. And so what we're going to do is we are going to divide every term by that largest power of x. So we're going to get the limit as x approaches infinity, and we're going to take our 3x squared and divide it by that largest power of x on the bottom, x squared. What we do to one piece, we have to do to everything. So we're going to divide every term by that biggest power of x in the denominator. And then simplify each of those little mini fractions. So 3x squared over x squared simplifies to just 3 in the numerator, minus 1 over x squared. In the denominator, we're going to get 7 plus 4 over x minus 5 over x squared. Now, if you multiply by the largest power of x that's in the denominator, you should end up with one number there that doesn't have any x's left in it. And everything else should be a number divided by x. And that's what we see that we have here. Because as x gets bigger and bigger and bigger, 1 divided by x squared is going to get smaller and smaller and smaller. 4 divided by x is going to get smaller and smaller and smaller. 5 divided by x squared is going to get smaller and smaller and smaller. So when we take that limit as x approaches infinity, each of those that have fractions left are going to get smaller and smaller to 0. And so that simplifies to 3 over 7, which is, if you follow the rules for horizontal asymptotes, you do see that if your degrees are the same, in this case x squared and x squared are our biggest powers on both, then we get that just those leading coefficients in the numerator and in the denominator give us the y value at our horizontal asymptote, which is what we're finding in this case. If we are looking at the limit as x approaches infinity and they're not the same, this same approach works. So again, we want to identify the largest power of x on the bottom. The reason we do it on the bottom only is because we always want to make sure that we have a number that does not go to 0, so we don't have zeros all the way across. So we always want to use the biggest power of x on the bottom. So we're going to do the same approach to this one. We have the limit as x approaches infinity of x to the fourth minus 81 over x cubed plus 8. Our biggest power of x on the bottom is that x cubed. So we are going to divide everything by x cubed. And when we simplify each of those little mini fractions there, x to the fourth over x cubed simplifies to x. 81 over x cubed doesn't simplify at all. In the denominator, x cubed over x cubed is 1. And then 8 over x cubed doesn't simplify. And so we see that as x gets bigger, this x is going to go to infinity minus 0. Well, infinity minus 0, 0 subtracting it doesn't do anything. In the denominator, we get 1 plus 0. And so we get that this is going to go off to positive infinity. All right, I'll see you guys next time.